Hey everyone, so this week in lab we're going to talk about, we're going to sort of go over Git and GitHub and how both the basics, which is sort of what I'm going to address, as well as how you can use the methods called forking and branching to manage the development process for your final project. And there are two things that we want to highlight here. The first is that one of the advantages of Git and GitHub is that it allows multiple people to contribute to a set of files, whether those files are visualization files or any kind of programming or web files that you might be working on in another context. But it lets multiple people contribute to one thing while still keeping track of kind of what's going on and making sure that nothing gets lost in the process. It also gives a way, so forking and branching in particular, gives you a way to essentially maintain that safe copy of something that you have developed. So maybe it's a chart that you have working, maybe it's a page layout that is really working for you. And by creating a branch, by creating a branch of an existing repo, you can sort of play around with features that then, if they work out, you can keep, and if they don't, you can just sort of throw it away without having touched the original. So we've sort of talked about this as part of the concept of having version control and having these incremental commits, but we're going to use that you're going to be able to use that in a much more active way for your final projects where you're working on a single file set over a long period of time and kind of continually augmenting it, and also working on file sets alongside or even kind of at the same time as your other team members. So to illustrate this, but for now, what I'm going to do is just kind of go over some of the basic things that have come up, a sort of basic kind of life cycle of working with Git and GitHub and with file sets, and also also to address some of the issues that have come up for a few of you during the course of your assignments. So as an example, I've created this folder called Final Project, and it's obviously empty right now. And I think what I want to emphasize here is that when you all are working on your final projects, we're going to give you teams on an organization called CJ Visualization on GitHub, and basically you'll have a team and you can create different repos for different pieces of your project. And you can do this by maintaining separate folders if you want, or you can just have sort of separate file sets. This is going to give you the ability to work simultaneously on things while kind of keeping an eye on sort of maintaining awareness of what everyone else is doing at the same time. So the way that I'm going to look at doing this is that I have a folder called Final Project, and within that folder I'm actually going to create a separate folder, and I'm going to call this Article 1. And inside of Article 1, I'm actually going to use a file set that an existing one from creating a chart in the past. So I'm just going to copy these and paste these straight into the Article 1 folder. And then I'm going to go into Git in my terminal window here, and I'm going to initialize a repo in Final Project. So I'm going to say, let's go to Final Project. Okay, I see that there's Article 1. And what I can do is I can say I want to add everything. So first I'm going to say git status, and of course it's going to tell me there isn't one. I'll say git init. And then I'm going to say git status, and I can say git add article 1. And by putting in the folder name there, I've actually automatically committed everything. Automatically added everything in that folder. And now, because I'm working with an existing file set, I'm going to go ahead and just say git commit a article 1. Oh, sorry, git commit a, and then the message is going to be initial. I can spell initial commit of all Article 1 files. Now, obviously, you may not decide to break things out that way, but the idea is basically that I can now, if I want to make changes within this folder, I can go ahead and make changes. You might have chart 1, chart 2, chart 3, probably. Actually, I'm going to say you should definitely have more descriptive names. But what I can do now is that I've actually created the repo in Final Project. And now what I want to do, because the final project is going to be my repo, I want to have a README on the repo that explains what's going on. Now, a couple of you ran into issues with this at the last assignment, and so I just want to go over the different ways that we can create a README. So the way that we've done this before is in the first assignment we did touch README. So touch will create a file with whatever file name and extension you give it, right? So again, if I do an ls here, all of a sudden I have a README. And I can open up this README, right? I can see it right here. I can open this up in Aptana. And it's going to be a blank file. Oops, there we go. It's going to be a blank file. This is the initial README. Okay, you would want to put in here, things like the pitches and summaries of your articles and charts that you can amend over time as they evolve. So this should kind of read always like the current state of your project, right? And different members. So this is a perfect example of a case where you're going to have multiple team members who are probably going to be editing this README file. And that's going to sort of go to this issue of pushing and pulling files that multiple people are working on, right? So it may be that I'm the only person who's working on the Article 1 file set that's in that folder, but all of us are going to be contributing to the README. And so that sort of life cycle of how you keep it up to date without also running into the merge conflicts that have been happening for some of you is a lot of what we want to focus on here. So I've gone ahead and created the README. I've now modified it. So I'm going to need to flip back to terminal. And if I say git status, it's now going to tell me that I need to add README, which is fine. I'm going to say git commit README, and the message is going to be start of README. Okay, pretty basic. My git status is now all set. So I want to now put this onto my GitHub repo. So I'm actually going to do this on the data visualization CUJ repo, and I'm going to call it Susan test, say SEM test project, and I'm going to keep this public. Now, we've organized so that you all can have private repositories on this, private repositories within this data visualization CUJ organization, because of course your final projects are going to include real files and real reporting, and we want to make sure that you're able to keep those private until your projects are finished, right? So we don't want to expose your work unnecessarily. I'm going to leave this public for now because it's obviously just a test. Now I want to point something out here. There is the initialize this repository with a README. So if I select this here, I'm going to run into a merge conflict. And the reason why is that I have already created a README on my hard drive, right, on my local version with Git, right? That's this README file. So just for an example, I'm going to go ahead and I'm going to initialize this with a README, and then I'm going to connect the two, and we're going to see how that generates a conflict. Okay, so I'm going to take my cloning thing here, and I'm going to flip back over and say, so just say git status, just make sure everything's cool. And I'm going to say git remote add origin, and then I'm going to say git push origin master, and it's going to say who are you? Put that in. Shoot, I forgot my password. There we go. Okay, so now I have a conflict. It's saying updates were rejected because the tip of your current branch, blah, 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 blah. But basically what it's saying is you got something different here than you got there, right? So in other words, here's my README on GitHub, but the README that I have locally looks, whoops, let's go find it, looks like this, right? So I've got something in here that is different, basically. So what I'm going to do is it's going to say, well, I don't like what you're doing here because you're trying to mix two different things together. And so That's a fast forward when I haven't pulled before I go to push, right? So this could happen to you all during your projects if somebody updates the README and you go to update the README, but you haven't actually pulled down the README first before making your changes. So I'm going to say then git pull origin master, and then it's going to complain to me about a merge conflict. And so you say your local changes will be overwritten by merge. Please commit your changes or stash them before you can merge. So first of all, I think in the midst of that, without even really thinking about it, which totally happens, I can say, okay, I'm going to say git commit readme made a quick change. Okay. And now I'm going to try to pull again. And now it's saying there's a merge conflict, okay? And so with these, then it says fix conflicts and then commit the results. So now if I reload my file here, what I'm going to see is something that looks like this. And it's basically saying, you know, this is where you are, it looks like this. And in the other version, it looks like this. So basically, this just sort of frames the conflicted areas. It just puts the two together and doesn't delete anything. And then it's up to me to go in and say, okay, actually I want it to look, you know, like this. Okay, I've decided this is what I want my README to be. I save it, right? And if you have multiple conflicts in a file, you'll see multiple sets of like caret things like that. So now I'm going to say git, I'm just going to say git status. You can see I do this a lot. So I'm going to say git. So now the issue is that it's going to say git add file to mark the resolution. So I'm going to say git add readme.md. And then I'm going to say git commit readme.md and a message fixed conflict. And then I get this cannot do a partial commit during a merge. So this has to do with kind of the inner workings of Git that we don't really need to worry about. But here is the answer. Thank you, Stack Overflow. So I'm going to use this git commit -i parameter. So going back to terminal, I'm going to do the same thing, except I'm going to say git commit -i. So what that does technically is it both quotes stages and then commits it. And now I fix the conflict. And now I can say git push origin master, and I can put in my and Viola. If I reload, now I have all of my files up there. And you can see that I have my README for my final project. It's got me down as 2 different contributors. That's weird. Don't know what's going on there. So anyhow, the issue is basically that what I want to do is, this is not to say that this is what you want to be doing most of the time, right? The real lesson here is that in general, before you start working on a set of files, you want to make sure that you pull from the original repository before you start making changes and pushing things, right? So the default thing is, so let's say, again, let's say I was, you know, someone on my team has made an edit to this. I'm just going to go ahead and do this online. Here's where I've added some content, right? So I do that. I can go down here and say, added some text. And I'm going to commit the changes. Okay, so now somebody else, some other team member has done that in the background. I'm going to work on my local file, and so I'm going to say git pull origin master. And what it's going to do is it's now going to pull that down. So basically, I'm now up to date with what is online, and that's the sort of process that I want to use. Basically, I always want to make sure that I pull, make changes, and then commit and push. Okay, you want to make sure you commit before you push. You want to make sure you pull before you start making changes, and that's kind of the general life cycle. So we'll come back in a minute and talk about a couple other issues, and then go on to branching for data management.